In this lesson, we're going to graph a parabola in standard form. So here we go. We've got this parabola, y equals x squared minus 6x plus 8. And as we said in class, the a, b, and c of this parabola, that is the coefficients of the x squared, the x term, and the constant, are as follows, 1, negative 6, and 8. So here we go to find the axis of symmetry. That's how we're going to draw this. We go right away to this very convenient formula that x is equal to the opposite of b over 2a. I'm going to substitute my values for a and b, and right there I've got the opposite of 6 over 2. That looks to me like it's going to be 3. So x is equal to 3. Remember, that's a vertical line. This is the axis of symmetry for this parabola. So everywhere here, you recall, these are all the values where x is 3, y can be anything, but that's a vertical line. That's our axis. So let's work on, well, I guess we need to find that vertex. And the best way to find that vertex, we're going to substitute, well, on my little chart here, I'm going to pick the value of 3, and I'm going to substitute 3 into the equation. I've got 3 squared minus 6 times 3 plus 8. Now you can work that out, and you will see that that's going to come out to negative 1. So right away, my vertex is 3, negative 1. Now there's an easier way to do it, but we're just going to count. I'm going to pick x values 1 unit to the left or right, one side of the axis of symmetry. I'm going left, and you'll see why in a minute. I'm going to look for values where x is 2, then 1, then 0, and then negative 1. So let's try it with, let's try x equals 2. I substitute there. It looks like 4 minus 12 plus 8. And that indeed comes out to be 0 right there. Okay, pretty good. Well, let's clean that up a little bit. And how about where x equals 1? So let's move over here. And I'm going to substitute 1 squared. Well, I'm going to have 1 minus 6 plus 8. Well, that's, I guess that's not too hard. I can see that that's going to be 3. All right, so I've got 1, 3 right there. And the shape should start to look familiar to you. We can solve, well, we can continue this trend. Let's solve for x is 0. Well, that one takes no effort because after all, this 8 is the y-intercept of the parabola. So we've got that right away. So now, let's go for one more. Let's go negative 1. And I'll put in for negative 1. And I can see that that's going to be 1 plus 6 plus 8. And that's negative 115. So there's half of your parabola. We can just reflect the points on the axis of symmetry right here. But also, I want you to notice this, the a term, that's just x squared. Remember, just plain old x squared. If I took this parabola, if I move, I'm going to move 1 unit to the right, up 1. Hey, that's 4, 0. From the vertex, I'll move over 2 and up 4. 2 squared is 4. From the vertex, I'll move over 3 and up 3 squared, or 9. And that's going to put me right there. And I could keep this pattern going. From the vertex, I'm going to move over, and this time 4, and up 16, and you know that that's what we're going to find. So indeed, your parabola is right there. If you want to compare it, look at that. That's the parabola, the parent equation, y equals x squared. Here is my parabola, y equals x squared minus 6x plus 8. Axis of symmetry is shifted over there, vertex down here at 3, negative 1. And let's graph another parabola in the standard form. This one, a little more exciting. Look at the a, b, and c there, all negatives. And, oh, and not to mention that, a shallow graph to boot. So we'll get right to calculating that axis of symmetry. Opposite of b over 2a. And when I do my substitution, whoa, heavens, to Murgatroyd's a lot of negatives. Negative, negative, negative. 3 of them used as products or quotients. That means, well, x is going to be negative. The 2's divide out. Well, dividing by 1/4, multiplication by the reciprocal, that's going to be the number 4. Yikes. Well, check that your arithmetic, but you should come up with x equals negative 4. So that's going to be your axis of symmetry. And I think you know what's next. You're going to put in negative 4 for a value of x, and then you're going to, well, you're going to calculate, nope, leave that there. You're going to substitute into the equation a little more arithmetic than the last one. Negative 4 quantity squared is positive 16 times the negative 1/4, negative 4 plus 8 and minus 1. So you can see right there, that's going to yield a 3. So I now have my vertex, negative 4, 3. Now, because you've done this before, I don't have to count by ones finding my values. I can pick any points at random. I love integral values. So I'm going to choose to look for these values of x. I'll count by 2's. Negative 2, 0, 2, and 4. Okay, let's do the next substitution. Well, at negative 2, the quantity squared is positive 4. Negative times negative 1/4 is negative 1. Lots of potential to make mistakes, so be careful. Be on your best arithmetic. So right here, you can see a small drop, and that's what you'd expect for a shallow curve. Now, evaluated at x equals 0, well, that's pretty obvious because the y-intercept is negative 1. It says so right there in the equation. Okay, let's clean this up and do just a couple more. How about here, where x is equal to 2? And again, the same thing. You can work that arithmetic out, and you will see 2, negative 6. One more time, a little bit more arithmetic. We'll try it this time with the number 4. And I can see it works out to 4, negative 13. So now, well, I've got a bunch of points right there. And I suppose I could I'm just going to say, okay, 2 units. I'm going to, on the other side of the axis of symmetry would be this point. I'm going to go 4 units across here. See, I'm just drawing. I'm just saying, okay, I know this graph is symmetrical. So 1, 2, 3, 4, 5, 6. And of course, then all the way down here, 8 units across. And I can see I've got a nice curve right there. And now, here we go. We're almost done. We'll just freehand to the best of our abilities. And let's go. Oh, that's beautiful freehand work there.